we worked on solving systems of equations. Okay, so that was finding intersection points of our two graphs. Today we're going to solve systems of inequalities, and in order to do that we have to graph them. Okay, so we're just going to graph the two equations we're given, and then we have to find where they intersect. Okay, so in example 1, I'm given these two equations here. So the first thing I do is identify what type of equations those are. Okay, so that top one, what would that top one be?
It would be something. What's that? Parallel.
Parabola. That one is a parabola. What's the second one? What does that equation look like?
Circle.
Circle.
Oh, nice.
Okay, so I have a parabola and I have a circle. I need to graph both of those equations. Okay, so your step 1 is to graph your equations. With this parabola, okay, it's in the form of y is greater than x squared plus 1. Okay, that means it's opening up, correct? Okay, what does this plus 1 do?
Up one.
Up 1. So from the origin, we're moving up 1. Do I have an A value or an H value in there?
No, you have an H.
No, you have a K. We already graphed the K part. So I don't have an A, right? That means from my point, I can just use my standard form of y equals x squared. So I can go right 1, up 1, right 1, up 3, and right 1, up 5. And I can do the same thing going to the left. So left 1, up 1, left 1, up 3, and left 1, up 5. Okay, so here are my points for that parabola. Now, for this one, I just have a greater than symbol. So when I connect those dots, this has to be a dashed line.
Isn't this supposed to be at 10?
What?
Yeah, isn't this supposed to be at the top?
At 10?
Yep.
Dang.
I counted to 4 instead of 5.
That's all right, I'm just a mathematician.
Thanks, Tyler. Okay, so when I connect my points, this should be a dashed line since it's a greater than symbol and it doesn't say equal to as well. Okay, so we're going to connect each of those points with our dashed line. Okay, next I want to graph this circle. Okay, when I graph a circle, I need the center point. What is the center point of this circle?
0, 0.
Yes. What is the radius of this circle?
9. Square root that.
Square root that.
3.
3. So your radius of this circle is 3. So I'm going to count to 3
From 0, 0
every direction. Yes. Now with this one says less than or equal to. So this is going to be a solid line. Okay? So here's my circle. It's a solid line. The parabola is a dashed line. Okay, your second step when finding or solving a system of inequalities, okay, is to pick a point plug into the first equation. Now this point cannot lie on your graph. So my first equation is this parabola. I can't pick any of the points that lie along that line, but I can pick any other point lying away from it. The easiest point to pick is 0, 0, as long as it doesn't lie on your graph. Well, with my parabola, 0, 0 does not lie on that parabola, so I'm going to choose that point. So I'm picking 0, 0 for x and y. We're going to plug in 0 for x and 0 for y. So over here, we have 0 is greater than 0 squared plus 1. So I have 0 is greater than 1. Is that true?
That is definitely not true.
That is definitely not true. Okay, now 0, 0 is here. It's on the bottom part of that parabola, right? So since that's not true, I need to shade inside this parabola. Okay, don't shade super dark. Just lightly shade inside that parabola. Okay, step 3.
Do the same.
Same thing with the other equation. So
But you can do 0, 0.
pick a point, plug into the second equation. Okay, so here is my circle. I'm just going to plug in 1, 0. Okay, so plug in 1 for x and 0 for y.
Or we're doing 1, 0.
1, 0.
How can
So
we
x
do that?
and y. What? Because it doesn't lie on the outside. So here I'll have 1 squared plus 0 squared is less than 9.
Why can't you use 0, 0?
You could. I'm just choosing a different point. So I have 1 is less than or equal to 9. Is that a true statement? Yes.
So shade everything inside.
So we'll shade everything inside our circle.
And then
Now when
shade
we're
dark.
solving,
coming pretty soon.
okay. When we're solving a system of inequalities, you want to see where the overlapping of the shading is. So that would be right here where my parabola intersects my circle. Okay, and you want to shade in darker than everywhere else. So that would be solving that system. Does that make sense? Yeah? So we've graphed all of these types of equations before. So you just need to graph them, pick a point, see if it's true, shade in that area if it is, or shade in the opposite area if it's not.
The circle is shaded, right?
Yeah, inside the circle was.
Why is it in that spot?
Because they both are shaded in that area. So that's your solution set. Okay, any questions on this first one? Okay, so I'm going to start looking at these equations here. So in example 2, we're going to do the same thing, but we have some different graphs here. So this top one, this top equation, if I have an x squared minus a y squared, what does that most resemble? Do you remember your equations?
Yeah.
What does that most resemble if there's a subtraction between them?
Hyperbola.
A hyperbola.
First one's a circle, right?
Nope.
No, that's a hyperbola. It's usually when it's x minus.
If there is that subtraction, it's going to be a hyperbola.
You heard?
Okay? So I'm going to rewrite this equation because for a hyperbola, it has to be equal to 1, or in this case, less than or equal to 1. So I'm going to divide both sides by 8. So I'll have x squared over 8 minus y squared over 8 is less than or equal to 1. So I just wanted to rewrite that equation there. Now our second equation, that x squared plus y squared is greater than or equal to 120, what one does that look like? What does it look like? What do we do in the top one? A circle. Okay, so I have a hyperbola and I have a circle. If you didn't know what it was, go back to section 6 where we used that discriminant. Okay, we found our a, b, and c value. And using those, we could tell what type of equation it was just by that given information. Okay, so you can go back and use that discriminant to tell which type this is. So what I want to do now is graph both of these. So for the hyperbola, we need to know its center, right? Okay, what is the center of this hyperbola?
Probably, I don't know.
Look at h and k. What are my h and k values?
Oh, 0, 0.
My h and k values are 0 and 0, given that equation. Now, in order to find your vertices, you need an a value, right? How do I find the a value given that equation?
Take 8 and square root it.
Yes. You take that first denominator and take the square root of it to get a. Okay, that's going to be about 2.8. Just going to round. Okay. Now I need to find my vertices. Okay, since I have my chart out right here. Okay, so since our x value is first over our a, this is horizontal. Okay, and to find our vertices, we're going to take h plus or minus a to get that x value. Okay, so we'll have our h value is 0 plus 2.8 is 2.8, and then k is 0. And take your h value again, 0, subtract 2.8 to get negative 2.8, and keep the k value the same. Okay, so these are my vertices. Okay, the other thing I need to graph a hyperbola is that asymptote slope. Okay, so your asymptote slope, that would be this one right here, this plus or minus b over a. Yep. Okay, so since a and b are the same here, right, they're both the square root of 8, it would equal 1. So I would have plus or minus 2.8 over 2.8, which is just plus or minus 1. Okay? So now I can graph this hyperbola. So to do that, I'm going to first graph my center is at 0, 0. Next, you need to graph your asymptote slope. So since it's negative 1 and 1, it's just going to go up and to the right one, up and to the left one. Okay, so it makes that X pattern. So I'm going to draw in my asymptote here. And then this one over here. All right, so these are my asymptotes. Next, I need to plot my vertices. So at 2.80 and negative 2.80. Okay. Then, before I draw in the hyperbola, I need to look at my inequality. So it is less than or equal to. So since it has that equal to piece, I can draw a solid line in for my hyperbola. Okay, so that's graphing my hyperbola. Next, I need to graph the circle. You know how to graph a circle. What's the center?
0, 0.
0, 0. What's the radius?
I don't know.
I reckon.
The square root of 120.
I don't know.
It's a decimal.
12.
There you go. So,
It's 10.95. It's about 11.
gosh, it's the whole thing.
I said 12.
Bigger.
What? I know it's not. Relax.
That's bigger than the square itself.
Okay, so here's 10. We'll go up one more each time.
Oh my god.
Out of bounds.
Yep, out of bounds.
That's
Fine.
not a fair catch then.
Okay, so here are all my points. Now this one is also an equal to one, so I can draw a solid line.
How are you going to see it on the outside?
Oh.
It looks like a square.
All right, so your next two steps are to plug in points for each graph. Okay, so I'm going to plug in a point for my hyperbola. For both of these, I'm just going to plug in 0, 0. Because on the graph of the hyperbola, 0, 0 isn't on that line. And 0, 0 isn't on the line for the circle either. Okay, so I'm plugging in 0, 0 for x and y into, I'm going to plug it into this one. Okay, so my first equation here, so I have 0 squared minus 0 squared less than or equal to 8. Okay, so 0 less than or equal to 8, is that true?
Yes.
Yes. Okay, so for my hyperbola, that means I'm shading everything inside over here. Okay, next I'm plugging in 0, 0 for my circle. So I have 0 squared plus 0 squared greater than or equal to 120. Is 0 greater than or equal to 120?
No.
No. That means I'm shading outside of my circle. Okay, now where both of these graphs are shaded is up here. Yep, above the circle and below the circle. Why? Because you're looking for the intersection of the shaded portions. So in your hyperbola, I shaded everything inside this way. For the circle, you shade everything outside the circle. So where they intersect is above the circle and in between my two hyperbolas, and below the circle in between my two hyperbolas, right here. Okay? So I'm going to show you on Desmos. I got to pull it up though.
Are we gonna be able to use that on the desk?
No.
Well, then why aren't we using
What
it
was
now?
that attitude?
I just have to graph it really quick.
Yeah, Mr. Jones said his favorite rapper was
Buddha.
because he's in Fast and Furious.
What do you mean?
Yeah, it gets harder.
No, it'll be fine.
My greatest actions are kind of going up. See, I was looking at
All right, so here's your graph. So where both of these intersect is this darker region, and that's what we shaded on our piece of paper. Okay, so that darker purpley region there and the darker purpley region down here. Okay, so that's what we were trying to find, that intersection of those shaded areas. Does that make sense? Kind of? All right, so last one. This one here. This is an absolute value function. Okay. This one, what does this one look like? What equation does that look like in standard form? An ellipse. Okay, so I have an absolute value function and an ellipse. Okay, so first graphing your ellipse, since that's the one we're more familiar with at this moment. For an ellipse, you need the center point. What's the center point given that equation? 0, 0. For an ellipse, we need to decide whether it's vertical or horizontal. Well, if my a squared value is my greater one, if that's under y, a squared under y, that's vertical. Okay, so this is a vertical ellipse. And we need to find the vertices and the co-vertices. So for a vertical ellipse, to find the vertices, we're going to keep h the same, so that's going to stay 0. And then we're going to take our k value and add a. Well, a, how would I find a? Do you remember? Square root of 36. In an ellipse, your a value is the greatest value. Okay, so that'll be 6. And our b value is the square root of 16. So 4. Okay, so for our vertices, we're keeping h the same, so that stays 0. Then we're adding k and a together. So k was 0 and a is 6. And our second vertice we'll subtract. So we have 0 minus 6. We get negative 6. Our co-vertices, we're going to, I want everybody to get written down. Co-vertices for vertical, we're going to take our h value and add and subtract our b value that we found. Okay, so our h value is 0, add our b is 4, and keep k the same. And then subtract 4, so we get negative 4, and then keep k the same from our center. Okay, that's all I need to graph an ellipse. So I can plot my center point. I can plot my vertices. So 0, 6, and 0, negative 6. And then my co-vertices, 4, 0, and negative 4, 0. Okay, and before you connect any of your points, you need to look at your inequality symbol. Since it is equal to, this is a solid line. So we'll connect those here. There. Okay, so here's the ellipse. Now we want to plot this absolute value function. Okay, so to do that, we can just make a XY chart if you want. Okay, so I'm going to plug in 2, 3, 4, and 5. Okay, so when I plug in 2 for x here, what happens when I plug in 2 for x here? No? We don't want
Sorry,
to
what was the question?
plug in 2 for x.
Okay.
2 times 0.5.
That would be negative 1.
Yep. Plus 2 is 1. Plug in 3.
Oh. Negative 1.5.
Plus 2. Okay, plug in 4. 0. 5. No. When you have an absolute value, if you end up with a negative, okay, it needs to be the absolute value, so it needs to become positive. Okay, so from here I can plot my points. So I have 2, 1, 3.5, 4, 0, 5.5. And if I plugged in 6, I would have gotten 1 again. Okay, so your absolute value needs to make this V shape. Before I connect anything, look at your inequality symbol. What should this line be? Dashed. Okay, here's this one. I gotta make sure it should go here to here to here. There. Okay, so here's my absolute value. Again, V shape. Next, I need to pick a point. Okay, again, neither of these lie on 0, 0. Their lines don't hit 0, 0, so I'm just going to pick 0, 0 as my point. So plugging in 0, 0 for my absolute value since it's my first equation here. I have 0 greater than negative 0.5 times 0 plus 2. So I have 0 is greater than 2. Is 0 greater than 2? No. Okay, so since 0, 0 was here, and it wasn't true, that means I need to shade above my absolute value. Okay, and again, just do it lightly. And then picking 0, 0 for my ellipse. I have 0 squared over 16 plus 0 squared over 36 is less than or equal to 1. Okay, and is 0 less than or equal to 1? Yes, that means I'm shading inside of my ellipse. Now again, we need to see where those shaded areas have in common. Okay, and that would be this portion right here. And I'll just shade that darker. Okay, and that would be your solution set for that problem.
First you did the